Hello everyone, my name is Vo Ding Cong Tinh. Today I would like to talk about the degradation of the electrolyte membrane in the proton exchange membrane fuel cell. Fuel cell is a conversion system. It can transfer from chemical energy to electrical energy by the electrochemical reaction. The proton exchange membrane fuel cell has three main parts. It is the anode, cathode, and electrolyte membranes. In the fuel cell operation, the hydrogen gas and oxygen gas was added at the anode and cathode side, and under effect of the Bt catalyst, hydrogen fuel was oxidized to the two hydrogen ions and release two electrons. The hydrogen ions will transfer through the membrane under the supporting of the sulfonic group into the electrolyte membrane and dehydrate state. Meanwhile, the electron will travel from anode to the cathode side in an internal circuit, generating the electrical output of the cell. Finally, is the reduction reaction between the proton and oxygen at the cathode side to generate the water molecules. However, during the proton exchange membrane fuel cell operation, the electrolyte membrane can be degraded by the thermal and mechanical factor, and the generation of the H2O2 is very important in the fuel cell operation because it is the root reason lead to the degradation of the electrolyte membranes. This figure is the mechanism how H2O2 is formed in the fuel cell operation, and at the anode side, under effect of the Bt, a part of the hydrogen can change to the hydrogen radicals, and these radicals can directly attack on the polymer structure or continuously react with the oxygen crossover from cathode to produce the H2O2 molecules. And thus the H2O2 molecules will be degraded to generate the OX or OOX radicals, and their radicals will directly attack on the polymer structure to begin the degradation process of electrolyte membranes. On the other hand, according to some studies, the concentration of the H2O2 is the highest at the anode side, and it will diffuse through the electrolyte membrane to the cathode. And on the way to the cathode, the concentration of the H2O2 will quickly decrease because it is oxidized by some metal ions to form the OX and OOX radical or the water molecules. And there are the four mechanisms how the radical can attack on the nucleon structure to begin the decomposition process. The first one is the attack of the OX radical on the carboxylic group to begin the decomposition of the main chain. However, when we compare with other mechanisms, the rate of this reaction is not strong. The attack of the OX radical on CS and ether bondings are the main reason lead to the decay of the output power density during the fuel cell operation because of the degradation of the functional group. Finally, is the attack of the hydrogen radical on the 30 carbon on both the main chain and the side chain of the polymer structure, and this reaction is also very important. Different with the nucleon structure, it containing all of ether group on the side chain of the polymer structure. The hydrogen polymer structure containing a lot of ether group on the backbone, so the radical will easily attack and degrade the main chain of the hydrocarbon membranes. So thank you for your listening, and next topic I will introduce some method how they can prevent the degradation of the polymer electrolyte membranes. Thank you.